Hello and welcome. We're now entering into our final chapter for this semester, which is Chapter 10, Growth. My name is Miss Delia, and if you're ready, let's get started with the lesson. So Chapter 10, Growth, is divided into three subtopics: 10.1, Measurement of Growth; 10.2, Types of Growth Curve; and 10.3, Growth Patterns. Now in this video, we're going to go into 10.1 and 10.2. So let's get started with the learning outcomes for 10.1. I hope that by the end of this segment, you would be able to define what is growth and also explain how growth can be measured. So we'll begin with the simple part by talking about the definition of growth. Growth can be defined as a permanent or irreversible increase in the size or dry mass or the volume or height or length or surface area of an organism in a specific time. Dalam arti kata lain, tumbesaran, growth, tumbesaran adalah proses di mana organisme itu dia membesar. Kita boleh katakan dia membesar dari segi dia punya size, dari segi berat, dari segi isi padu, panjang, tinggi, dan keluasan permukaan organisme itu. Okay, pada specific time lah. So the time is like, the day it was born, or months after, years after, etc. So this is one of the ways that you can define growth. But sometimes we also use another definition. The other definition is growth is a permanent and irreversible increase in size, increase in dry mass, volume of cytoplasm, and number of cell or differentiation of cell in specific time. So if you're looking at organisms like humans and tall trees or cats and dogs, then the first definition is no problem. But sometimes you're looking at different types of organisms, say for example a bacteria, then you might want to use the second definition more. So let's have a look at that second definition. Growth is a permanent and irreversible increase in size. Okay, so kita boleh tengok dia dari segi size. Kita boleh juga tengok dia dari segi isi padu cytoplasm, volume of cytoplasm. So if you have a unicellular organism, say for example you have one paramecium unicellular, pada asal dia kecil macam ni. It's like this small. But then after several weeks, it becomes this big. So that is an example of how a unicellular organism's growth can be measured in the volume of its cytoplasm. Or you can also look at the number of cells in that organism. If it is multicellular, you can look at number of cells. If it is a population, you can look at the number of cells in that population. Or you can also talk about the differentiation of cell. Kalau kita cakap pasal embryo pada chapter sebelum ni, if we think about the embryo that we learn about in 9.3, then when that embryo went from just a ball of cells, and those cells, instead of being just called a blastula, it now becomes a gastrula with layers of ectoderm, mesoderm, endoderm. That means the cells have undergone differentiation. Okay? Kalau organisme yang kita tengok itu masih mempunyai bilangan sel yang sama, tapi sel dia sudah mengalami pengkhususan, differentiation of cell, then that is also growth. Okay, so there's many ways to define growth, but these two are the usual definitions that we will use when we want to define growth. Okay, so we've already defined growth. We know what growth is. Now we want to measure the growth of an organism. Kita mau sukat tumbesaran sesuatu organism atau populasi. So to measure growth, you need to first decide on a method that is suitable with the level of organism. When we talk about level of organism, what we are asking is your organism unicellular or multicellular? If it is unicellular, what is a proper way to measure its growth? If it's multicellular, what is a proper way to measure its growth? And what is practical? So let's have a look at unicellular organisms first, also called microorganisms. You cannot measure them individually. They're very small. It's almost impossible to measure them individually. So what we do is we measure them by colony. An example is bacteria. So let's have a look at this image down here. This image down here is a petri dish that has colonies of bacteria growing on it. So, kamu nampak yang setiap bulatan, okay, ada bulatan yang oranye, ada bulatan yang merah, ada yang kuning, ada yang putih. Setiap bulatan itu adalah satu koloni bakteria. Jadi, bila kamu mau sukat tumbesaran organism, microorganism, kalau kamu boleh biak dia untuk hasilkan koloni seperti itu, then kamu kira lah, dalam petri dish ini, cuba kira, ada berapa koloni di dalam. Okay, so that's pretty much it for unicellular organisms. What about for multicellular organisms? For multicellular organisms, you can measure them individually since they're big, so boleh sukat satu individu seterus. And the measurement of a multicellular growth is usually done by looking at the wet mass or the dry mass of the organism. Kita tengok dia punya berat basah ataupun berat kering. And of course, an example of a multicellular organism is you. Alright, so now we've talked about what are the measurements of growth that we can do for unicellulars and multicellulars. Let us focus on that part about wet mass and dry mass. Kita fokus dan cuba lebih memahami apa itu berat basah dan berat kering. So we'll first look at the wet mass. So over here we have a kitty cat on a scale. So that gives you an idea what a wet mass is. It's when you measure the mass with its water content. Kita terus timbang organism tersebut termasuk kandungan airnya. So the advantages of using the wet mass of an organism is you do not need to kill the organism. So this is what we call non-destructive sampling. Kalau saya mau timbang berat miau ini, saya tidak perlu kasih mati miau ini. Saya cuma perlu angkat dia dan letak dia di atas penimbang. And by doing so, I can monitor continuous growth of this organism. I can make repeated measurements in the same organism. And this is possible because I'm only taking the wet mass. So pada minggu pertama, saya timbang kucing ini. Minggu kedua, saya timbang lagi. Minggu ketiga, timbang lagi. Dan saya boleh tengok proses tumbesaran kucing ini dari minggu pertama ke minggu kedua, ketiga, keempat, dan seterusnya. Okay, so that is continuous growth. You measure the continuous growth. And it's the same organism. It's not a different cat. But it's not perfect. There are some disadvantages to taking the wet mass of an organism. The first one being it does not measure the true growth. Okay, dia tidak akan menyukat tumbesaran sebenar ataupun kita boleh katakan dia kurang tepat. Inaccurate measurement is because there is fluctuation in water content. So if the cat is dehydrated, it's going to be lighter. If it's drinking a lot of water, it's been having a lot of fluids, then it's going to be heavier. And all organisms will vary even though they are the same size and age. So kucing 1 tahun yang pertama dengan kucing 1 tahun yang kedua ekor ni, walaupun dia sama umur dan nampak sama besar, berat dia mungkin tidak sama. So it is inaccurate measurement. So yeah, that's pretty much it. Those are the advantages and disadvantages of the wet mass. Let us now look at the dry mass. What does it mean by dry mass? Dry mass is when you measure the mass of the organism without its water content. Berat kering. So kita kasih kering organism itu and then kita timbang. There is a good advantage to this method because it gives you an accurate measurement of that organism, especially when we're looking at plants. So inaccuracy because of water content is already removed. But there are a lot more disadvantages than advantages. The disadvantages being that if you are taking the dry mass of the organism, you need to kill the organism. So if you kill the organism, that is what we call as destructive sampling. The sample will be destroyed after you take the measurement. You also cannot monitor or measure the continuous growth. Kalau kamu sudah kasih kering pokok itu hari ini, kamu sudah cabut dan timbang, hari keesokannya, minggu yang seterusnya, tahun hadapan, kamu tidak dapat sukat sudah pokok yang sama. And also, killing and dehydrating the whole organism is unethical if you are doing data collection for animals. I'm sure you don't want to kill a cat every single time you want to measure its dry mass. Another disadvantage for the dry mass method is you need many individuals from a population with similar age and size to measure the growth, change, and minimize error. So, contohnya kamu mau tahu kalau pokok spesies ini, pokok bunga raya lah contohnya. Pokok bunga raya nih kalau dia sudah tumbuh selama 1 tahun, agak-agak apa berat kering dia. Then you cannot just use one pokok bunga raya. You have to go and find several other pokok bunga raya for your data to represent the whole population. Baru data kamu lebih tepat sebab dia mewakili keseluruhan populasi pokok bunga raya. So you have to kill a lot of plants basically. Dry mass is accurate, but we mostly use it for plants, less for animals and humans. Okay, so then we've already talked about the wet mass and the dry mass of the organisms. That brings us to the end of 10.1. In 10.1, we already defined growth. And after we define growth, we talk about the measurements of growth, what are the different ways that we can measure growth, and which methods is more suitable for what organisms we choose. And after that, we can collect data. Lepas kamu pilih cara kamu mau sukat tumbesaran organism kamu, kamu boleh kumpul data. And after you've collected your data, you can plot the data on a graph. Okay, kita plot pada graph. And after you get the graph, you can draw a growth curve. Kita boleh tengok trend pada graph tersebut dan lukis growth curve. So that brings us to the next segment in chapter 10, where we talk about the types of growth curve. So in 10.2, types of growth curve, I hope that you would be able to explain what is an absolute growth curve and also explain what is an absolute growth rate curve. So let's have a look at the two types of growth curves that you need to learn about in this subtopic. The first is this, the absolute growth curve, and the second is this, absolute growth rate curve. So you can already see their appearances are a bit different, and if we want to translate them to Malay, if we say growth is tumbesaran, absolute growth means tumbesaran mutlak, absolute growth rate is kadar tumbesaran mutlak. Okay, so now we're going to look at absolute growth curve in more detail. So what is absolute growth curve? Absolute growth curve is the basic of most growth curves, and it is commonly shown as a sigmoid curve or an S shape as such. It shows the overall growth pattern and how much growth has occurred over a period of time. So when we want to draw the absolute growth curve, this curve is obtained by plotting the growth parameter against time. So for example, we can take the height or the weight of the organism and plot that against time. So this will show the increase in the size or mass over a period of time. Examples of absolute growth curves are the sigmoid growth curve and the human growth curve. The human growth curve is a bit like the sigmoid, but it has two sigmoid curves. Now we're going to look at these two examples one by one. Kita akan start dengan sigmoid growth curve dulu. Kita tengok apa itu sigmoid growth curve. Sigmoid growth curves can be used to look at the growth in an individual organism or in a population. If you're looking at the individual organism, then what are you going to measure is going to be the height or the mass or the volume of that organism. If you are looking at the growth of a population, then you want to measure the number of organisms in that population. The sigmoid growth curve that you get from measuring either individual organisms or populations is going to be S-shaped. They are the general patterns of growth in most organisms and populations, and the curves on the S-shaped curve can be divided into 4 phases. So if we look at this graph over here, this is a graph showing a sigmoid growth curve. So inilah bentuk S yang kita katakan. In this graph, we are looking at the parameter of population size, so number of individuals in a population over time. It's already divided into 4 phases. Can you have a guess what are the names of each of the 4 phases? If you're ready, let's have a look. The first phase is called a lag phase. The second phase is called the log or exponential phase. The third phase is called decelerating or linear phase. And the fourth phase is called the plateau or stationary phase. So we'll look at each of these phases in detail using the example of looking at a population size. We'll start with the first phase. So in a population, if we say it is still in the first phase, we say it is in the lag phase. What happens in the population is that the reproduction or the growth rate of the population is slow or little. The organisms in this phase are still adapting into a new environment. They are just being introduced to a new environment, so they're taking their time to adapt. The number of individuals in the population at this phase is very low. There are no limiting factors, which means there is an abundance of resources. Nothing is stopping them from growing. Okay? Dari segi kemudahan, semua kemudahan ada. Semua sumber masih banyak. And there is no waste accumulation. Okay? Bahan-bahan buangan. So, bahan buangan ini bolehlah daripada organism itu sendiri. So, it can be excretions from the organism itself. Or if we're talking about organisms like humans, then that waste can also be the garbage that we leave behind. As a result, there is less or no disease due to toxic waste. Sebab kurang bahan kumbahan, kurang sampah-sampah, kurang bahan buangan toksik, kurang penyakit yang disebabkan oleh bahan buangan. Kalau kita tengok secara ringkas, ini adalah fasa penyesuaian diri untuk populasi ini. Tidak banyak yang berlaku sebab mereka baru sahaja mahu menyesuaikan diri kepada persekitaran baru. Bila dia sudah sesuaikan diri, when it's already used to the environment, it will go into the next phase, which is called the log or logarithmic or exponential phase. So you can use any of those 3 names. And what happens in the log phase is that the population growth or reproduction rate is rapid or at its maximum. Because it is growing and reproducing very rapidly, the number of organisms is also increasing rapidly. In this phase, there are no limiting factors, so there is still an abundance of resources. It is still in a period with no constraints on growth. Okay, dari segi sumber, semua sumber yang dia perlukan untuk terus membiak, terus hidup, masih banyak dan tiada benda yang menghalangnya daripada terus membesar. There is sufficient food supply, so that means there is sufficient nutrients in the environment. Water is sufficient and there is availability of space or shelter. So there is space for every individual to live in this environment. There is also no accumulation of waste materials. Okay, belum banyak lagi bahan buangan yang terkumpul. So there is less disease due to toxic waste. In other words, this is the best time for these organisms to be alive. It is when enough food, enough water, enough shelter, enough everything, and all they do is live and reproduce and really just enjoy living in this environment. But this phase will not last forever, because later this population is going to enter into the third phase, which is called the decelerating or linear phase. So what happens is, in this phase, growth will slow down or decrease or becomes limited. Why is growth slowing down? It's because growth is limited by internal factors and external factors. Examples of internal factors is the metabolism of each of these organisms, each of these individuals may be slowing down. Or it could be because of external factors such as there being limited food, limited water, limited space, and competition between individuals. In this phase, usually there will be limited space or shelter, or we can also say the population is experiencing overcrowding. Terlalu banyak individu untuk kawasan yang kecil. As a result, in this phase, you would also have accumulation of waste materials. So di fasa ini start kita nampak kumbahan, bahan buangan, sampah sarap menjadi masalah yang lebih serius. So you have more accumulation of these waste materials. It will lead to contamination. And this contamination will give rise to diseases and health problems. So this is the time when it goes from a very happy population to being a little bit not very happy. And last but not least, this population will enter into the fourth phase, which is the plateau or stationary phase. In this phase, the overall growth of the individual or population is stopped or ceased. It becomes constant. And this is the maximum size of population achieved. At this phase, the birth rate of the population is equal to the death rate of the population, which means the rate, if we're looking at the individual or looking at microorganisms, then we say that the rate of division is equal to the rate of cell mortality. Bilangan sel yang terhasil daripada mitosis adalah pada kadar yang sama dengan kadar di mana sel-sel sedang mati. Of course, the cells are still dividing. Dia bukan berhenti mitosis. Dia masih lagi lakukan mitosis. Tapi kadar mitosis dengan kadar kematian sel adalah sama. If we are talking about a population, for example, in animals, then you can say that at this phase, the number of animals being born and the number of animals dying is the same. It is in this phase where the population reaches its maturity. Or you can also say the population has reached its carrying capacity. At this phase, there is no more growth in the population. Memang begini sejak sampai penghujung. So this is called the plateau or stationary phase. So those are the 4 phases in a sigmoid growth curve. Of course, in different books, you can also have different names. But usually, for the first phase, all books will call it the lag phase. The second phase, you can call it log phase, exponential growth, logarithmic phase, semua pun boleh. The third phase, sometimes we call it the deceleration phase. And the fourth phase, instead of plateau and stationary phase, you can also call it a stable equilibrium phase. Yang penting, kamu ingat bentuk sigmoid curve macam mana dan lebih kurang apa yang berlaku pada setiap fasa pada sigmoid curve. Okay, so that's pretty much it for the sigmoid growth curve. Now we look at the human growth curve. The human growth curve is consisting of 2 sigmoid curves or 2 S-shaped curves stuck together. It has 5 major phases, so you can divide this into 5 phases, which is infancy, childhood, adolescence, adulthood, and aging phase. Okay, start daripada baby, budak, remaja, dewasa, dan orang tua. So in these 5 phases, you are going to see 2 rapid growth phases and 1 slow growth phase. So before I show the answers, can you have a guess which ones are the 2 rapid growth phases and which ones are the slow growth phase? The rapid growth phases are during infancy and adolescence. So dua fasa ini adalah di mana kadar tumbuh besaran adalah paling cepat. Dan slow growth phase is during childhood. So masa kamu kanak-kanak, kamu memang sedang membesar, cuma pada kadar yang perlahan. Okay, so now let's have a look at each of these phases in detail. We'll look first at the infant phase. So this starts when you're just born until you are about 2 years old. During this phase, the growth rate is very rapid for both genders. So whether you're a boy or a girl, you're going to grow very fast when you're a baby. The cells will be dividing very rapidly. And as the number of cells increase, the size of the infant will increase even more quickly because now there are more cells carrying out cell division. But there is a limit to this rapid phase of growth. After that rapid phase of growth, it becomes limited and it enters into the childhood phase. The childhood phase, zaman kanak-kanak, this is when your growth rate is slower. As I've said before, you're still growing, just at a slower rate. So from the age of 4, usually, you would see there is a higher growth rate in males compared to females. So daripada 2 tahun hingga 4 tahun, lelaki dengan perempuan membesar lebih kurang pada kadar yang sama. Bila lebih kurang 4 tahun, budak lelaki akan membesar pada kadar yang laju sedikit berbanding dengan perempuan. However, this childhood phase will be longer in males than in females. Okay, budak lelaki akan berada dalam fasa kanak-kanak, childhood phase, untuk lebih lama. Okay, daripada dia umur 2 tahun sehingga dia umur lebih kurang 15 tahun. Berbanding dengan perempuan berada dalam fasa kanak-kanak dari dia umur 2 tahun sehingga dia umur lebih kurang 11 tahun. So, girls will enter into the next phase when they are about 11 years old. That next phase is the adolescence phase ataupun zaman remaja kamu. In your adolescence, the growth rate is very rapid. Your body will be growing very fast. In the earlier phase, females have a more rapid growth. Females will enter this phase at a younger age, okay, about 2 years before it begins in males. And in the later phase, which is when males enter this phase at an older age, male growth rate will be higher compared to females. This difference results in the females attaining puberty at an earlier age, around 12 years old, compared to the males around 14 years old. However, the average normal puberty will occur between ages 9 to 16 years old in males and females. Okay, essentially what this text is saying, you grow very fast when you are a teenager. For boys and girls, it's going to be different rates, but all of you would have entered puberty between the ages of 9 and 16. Okay, kita akan masuk akil balik lebih kurang pada umur 9 hingga 16 tahun, tidak kira kamu laki atau perempuan. Tapi biasanya perempuan duluan. Okay, so this is a graph that shows the difference in the male and female human growth curve, especially during adolescence. So you can see here, the ones with the crosses, yang X itu adalah graph untuk lelaki, dan yang bulat itu adalah graph untuk perempuan. So kita tengok di sini, masa mereka kanak-kanak, okay, during childhood, you see that boys grow a little bit faster. If you remember when you were in primary school, okay, when you were in year 1 to year 4, the boys were taller than the girls. But after some time, the girls are going to have a higher growth rate. So if you remember, between when you were in year 5, okay, darjah 5, sampailah kamu lebih kurang form 2, form 3, perempuan akan lebih tinggi daripada lelaki. It's because of this difference in the growth rate. But entering into form 3, form 4, form 5, the boys would catch up, and most of the boys would be taller than the girls at this stage. So that is what we are saying about this difference in the growth rate in childhood and also during adolescence. Okay, and after your adolescence, lepas kamu siap jadi remaja, kamu akan masuk fasa dewasa. Okay, you're going to enter into the adult phase. So remember, when we talk about this adult phase, we're simply talking about the growth of the body, the physical body. Emotional maturity, emotional growth is another thing. So we're just going to look at maturity and growth of the body. In the adult phase, your growth rate is 0 or constant, or we can say your net growth of your body is 0. So what that means is most individuals would have attained physical maturity. Females will achieve this phase around age 16 and males will achieve this phase around age 18. But there is plus minus for every individual around the world. Okay, so pada fasa ini, like, you stop that rapid growth already. And you kind of stay the same with the growth rate of 0 until you reach a certain age where it considers as an aging phase. Okay? Kalau masa kamu dewasa, dia macam constant saja kan, tidak perubahan badan kamu. Pada sampai satu masa, bila kamu tua sudah, badan kamu akan start deteriorate. It's going into a negative growth rate. So what it means is that during the aging phase, there are more cells dying than there are cells being repaired, than there are cell mitosis. We can also say this is the phase where you experience senescence. Senile. Okay. And the growth starts to decrease starting from the age of 30. So when we are still in 30-ish years old, it's not like we're gonna start dying, but that is when your body slowly has a more negative growth rate. When you reach age of 65, 70, 80, your growth rate is even more negative and it becomes more obvious. Okay, so that's pretty much it for the human growth curve. What is most important for you learning about the human growth curve is you should be able to name the 5 phases. Talk about the growth rate. Okay, is it rapid? Is it slow? Is it negative? Is it zero? You can talk a little bit about if the cells are dividing quickly or if they're not, and if there's any difference between males and females. And that's pretty much it. Okay, so in absolute growth curve, we already talked about the sigmoid curve and the human growth curve. And now we're going to enter into the other segment in 10.2, where we learn about the absolute growth rate curve. So, talking about absolute growth rate curve, it is the curve that shows the total growth of an organism throughout the growth period, or we can also say it shows the growth rate pattern over time. It commonly shows a bell-shaped curve. The bell-shaped curve is obtained by plotting a graph of growth rate or growth parameter against time. And then this curve will also show where the growth is maximum and how the growth rate can change with time. Remember, ini adalah graf yang menunjukkan kadar tumbesaran. And it also shows the increase in mass per size per unit time. Okay, so the unit for the growth rate is usually kilograms per year or kilograms per week, something like that. So this is what that absolute growth rate curve would look like. Okay, so you can see the bell shape very clearly. And on the left, what we have there is the table that has the data we used to make this curve. So dalam table di sini kamu boleh nampak dia ada dia punya time, yaitu this is time in days. Then you have the height, initial height, final height, and height increase or difference in height. So what we use to plot this graph are these two columns. We plot these two, and then we can also find the maximum point. The maximum point is where you have the maximum growth rate. It can also be called as the inflection point. And you can also find the same point on the graph over here. Okay, so once again, another diagram that shows the growth rate curve. This time, it is also in the height versus days. Once again, showing the maximum growth rate curve. And here is a comparison between the absolute growth curve and absolute growth rate curve. So you can see here, on the absolute growth curve, the maximum growth rate is somewhere in the middle. And whereas the absolute growth rate curve will show the maximum growth rate point very, very clearly. Kalau kamu ada graph absolute growth curve, kamu mau jadikan dia kepada absolute growth rate, what you can do is you can go and measure the gradient at each of these points. Okay, kamu sukat dia punya gradient. Lepas tu gunakan gradient dia untuk plot graph di sini. So that's something that you may have covered in your maths lessons. So maybe refer to what you learned about there before. Tapi kalau kamu tidak mau kisah pasal dia punya gradient, macam mana graph dia terhasil, that's fine. We'll just continue with the next slide. Okay, so in this next slide, we talk a bit more about what are the comparisons between the absolute growth curve and the absolute growth rate curve. So you can talk about how you get each of these graphs, what the shape of the curves are, and what data is it showing. In the absolute growth curve, it is showing the overall growth pattern and how much growth has taken place over a period of time. So dia fokus kepada tumbesaran yang berlaku. Absolute growth rate curve shows when the growth rate is maximum and how the growth rate changes over time. So dia tengok tren perubahan kadar pertumbuhan atau kadar pembesaran. Okay, so the absolute growth rate curve focuses on finding the inflection point or the maximum point and looking at the trend. Okay, so once again, pointing out that the parameters that we're talking about, it can be the height or the mass or the surface area of the organisms, etc. Okay, so I will end the video here. So in this video, we've already talked about 10.1 and 10.2. In 10.1, we defined what is growth and also talked about the different ways of measuring growth. And then we discussed what is an absolute growth curve and absolute growth rate curve. There's not much you need to do by the end of this video. All you have to do is continue on with the video for 10.3. So that's all from me for this segment, and I'll see you in the next video. Thank you. Bye.